Okay guys, welcome to my channel Network Simple, and today we're gonna walk through together virtualization. So what is a virtualization? Now virtualization got two different parts, and those two parts are called server virtualization and network functions virtualization. Virtualization itself means you want to create a computer inside your computer. So you want so the concept of virtualization comes in allocating your RAM, your CPU, and storage. So how you want to maximize these three is why we are going to use virtualization. Now you might try to understand this part as you got a PC 32 GB, like it got a RAM of 32 GB, and it got a storage of 2 TB, and you you have a processor, you have a good Intel processor. Now you have a good processor. You think, okay, you're just using Microsoft Word, you're just for uni environment, but you got this high end stuff. You wanna maximize it. You wanna have money through it. You want to This is the potential you have right now. So virtualization comes in. It will tell you, hey, I want to rent half of my resources to other people. How can I do it? And I want those resources to act certain way, which is firewall. Some people wants to use it as a firewall. Some wants a storage, and some want to mine a crypto. So what do you do with it? You let them host on your PC. Now this PC will be limited. So you want to create this PC for you want to hold maximum capacity, so that means you want to hold 100 GB RAM, 50 TB of 50 TB of storage, and processor. You want to have this processor. So server virtualization comes in. It's a dedicated virtualization platform, which instead of having your PC, it's now a bigger PC, and it contains the OS to manage this. Now network functions virtualization, it means you turn your the virtualization part to do certain things. This is called functions virtualization. Okay, so the way I can give you the example for this part is that we have you have you want imagine you want to install a game, but and you're installing that game on your PC, or you will get that game on the PS5. What's the difference? Now this is where the type 1 and type 2 comes in. In the type 1, which is the PS5, it's dedicated for playing. It's dedicated for you to have the best way to have to run the game. But the PC, some PC can the old PC, it cannot handle newer games. So you don't have the set standard for you don't have you're limited by the processor, by the RAM, by the graphic. But PS5, it's also limited, but it's dedicated. It is known to handle these games. Anyways, so this is where the type 2 comes. In the type 2, you install the workstation, which is VMware workstation, and within the VMware workstation, you create you you create the servers. That means from your PC, you have the 8 GB RAM. In the VM workstation, you're gonna create a virtualization desktop, which is your PC. Another, it's virtualizing this desktop itself means you're trying to create the another PC, and that PC has 4 GB and few processors. So this is the difference between type 1 and type 2. The type 1, you have the larger capacity to have more RAMs, more storage, and more processor. So when you and within and you can migrate with it. You can play with both of them, can do the same thing. So we come to the part of the containers. Now container, in one word, it's an application. It's another application like the VS Studio Code. There are all applications, right, to run to run Python, to run JavaScript, to run C++. Just like that, the this container holds that concept. Now, the container's objective is to create a standardized version of application that lets you host to other devices. Now, what this mean itself? It means my the way my one files run in my PC, it might not run on the mobile, or it might not run in the Mac. So this container, which is this another word called Docker, it lets you run your PC to everywhere. So you have Shopify, you have TikTok. These are the they need this they need uh, to run these apps on your phone, on your PC. So it's one of the it's just that it's one of the application they want the this PPT, which is this presentation, it wants to separate itself from the VM. Now the differences between the containers and the VM is that the VM, it tries to host on your PC itself, while uh, while the container is an application itself. And that's all. And I added the reference file, and I'm adding a reference YouTube to for your more research about the container. But this is the summary of the container and the VMs. Okay, so what is the virtual switching? So what does this words mean? Inside the server that runs VMs, you need way for VMs to talk to each other, and the physical network, which is our internet. So the internet we are connected with. How can I share that connection with the VM? This is where virtual switch and the network adapter part comes in. PNIC, a real physical network in the server. PNIC is the Ethernet port that we see. That's called NICs, by the way. And virtual NICs, it's meant the virtual Ethernet ports, like that. If it doesn't have, VM can only talk internet. So I want to show you how VNI works. Virtual configuring NIC for virtual machine with hyper. For virtual machines, we have the. Now we go to the network. This is how it looks like. You can go through more about how the virtual machine, but this is the visualized way of seeing the how virtual switch works, and this is what we will get at the end of our virtualization switching. And then you got the many switches to needs to be going in it. We have, as we have many switches, we need the main switch. So the main switch, which you will be connected from the, as it got Ethernet E00, it will be connected to Ethernet E00 and Ethernet E01 in the real life, right? So that's the same concept they use in here. We have the core switch, and then we have the distributed switches. Now, network functions virtualization. In the network functions virtualization, they want firewall, router, switch, IDS, IPS, all within one device. So, of course, and in this slide it talks about the benefits. Of course, when you don't have, when you're doing a hardware when you're handling this all in one hardware and then using appliance for that, it becomes easy. These are the uh, appliances that holds virtualization. Okay, so we know this is so we know VM wants to manage. So we want the VM to manage our CPU, RAM, storage, and network. So what this service chain does is that it connects the ID. It builds a fixed system that creates the fixed system of creating a flow that from IDS it will go to the firewall. From the firewall it will go to the router. So this chain flow is called service manager. Now how is it maintained? We have this called element manager. So element managers are responsible for functioning management of VNF. So if the virtual appliances, which is the firewall, if one of them get down, or we need to monitor them, are they down, are they working well, or what is their performance, EMS does that. And VNF, like the NFV, VNF, the NFV is for creating and maintaining tree of VNF. So when they are combined together, the service manager and the NFV, we get this called management and orchestration. So the settings panel that for so it create the EMS is so EMS is the dashboard, the GUI, and the GUI contains this NFV orchestrator. VNF manager NFV orchestrator controls the live start. So inside the orchestrator, we need to stop and all. So we go through the VNF manager. Together they are called management and orchestration. This is just the name for the group. EM often work but works beside them. EM, each virtual manager controls the device like the orchestra connects all the. So now I had the question, why the slide service, what is the relationship between the service manager and this mano? You saw the service connect service chaining connecting virtually in order so traffic flows in. Service is created by the NFV orchestrator, which VNF to use in what how traffic. So that again is built by the orchestrator. This is the main point I want to say. Once the creator VMS starts the IV, this is the flow. VNF manager starts the VDF, starts the firewall, monitors and restarts. Without that, the chain can break. The element manager configure the firewall, configure the IDS, configure the router. Okay, so here the connects VN start those VN keeps them healthy. Let's see configure. That's all. So we have the configuration, the manager, and the orchestrator. So OSS is the service provider. When you have a problem with your internet, you call them the OSS, and when you have a problem with your billing, you call the BSS, which is the business support system. That's all. Okay, so we have this five terminology: input, output, and input output device. In the so input and output is the movement of how your CPU is uh, how your CPU is connected. How is your CPU receiving the keyboard, the mouse? How does it click with it? So it's called the connection itself. Now interrupt request. So hardware signal sent to the CPU by an I/O device to notify when it has transfer. When the CPU receives the inter blah blah blah. Cut 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 cut. Okay, so we got five terminology, which is the first thing we need to keep. The main word we need to understand is the I/O, input and output. So input is our keyboard, okay, and the output is what we see, which is the monitor. So input comes. There's another word called in for the input is where that will be mostly highlighted is the NIC card. Now that NIC, you see your Ethernet port, right? So that itself is called NIC card. And we have the kernel and the user space. The user space means your apps like Google Chrome, your web, and the kernel uh, is this. This is the kernel. It manages your CPU, your memory. So this software, which is your BIOS, it handles this part of your CPU, your RAM. It connects your RAM, memory, storage with that software is allows them to connect and manage your PC. Okay, so direct memory access is now for when you connect your mouse, when you connect your printer, how will it transfer the data? So that word is called memory, direct memory access, to send or receive directly to or from the memory. And then we have the device driver that allows communicate with the device driver, and that requires a driver to operate with the CPU. Now, okay, this part will be confusing. So this three part, I'm confused as well. So this is the scenario. This is the answer that's coming up. Input and a packet comes from the Google to enter your PC. The NIC card is the IO device handling. The NIC, which is your Ethernet port connected to the service providers, which is the people that gives you the internet. And then interrupt request. The NIC tells the CPU, I gotta come process it. So, you receive, you want to go into the uh, Google. Okay, now when Google sends its packet, hey, you can you're you're getting receiving the packet from the Google. Uh, uh, you're receiving the packet from the Google. The CPU, this part, the interrupt request, the CPU it processes. That's why you will see that I'm getting two. That's why you're seeing that I have this many CPU's activities running, and there's memories also. I have a high memory also. So this comes from the packet I'm receiving, and it's processing. The device driver tells the packet from the OS it can be read until a driver loads and let the packet from it. This part I still don't understand. Okay, the DMA directly, instead of giving data to CPU, the NIC puts the packet directly to the RAM. So the load is being shared by the RAM is taking the load from the CPU, handles the user, the firewall, VM application process the packet. Okay, now this two part we didn't understood. No, the device driver. Exactly, yeah. So the device. So this is the main point of the driver. This extension, I don't know, Windows isn't, so they want also social. All right. So that's the view for the for the network functions. Chrome kernel user space, your COM, your VMs, kernel your drivers, kernel handles your CPU, and okay. So that's for this part. Now we come to the part of virtualized environment. Now let's understand this diagram. So how packet flows in the virtualized environment, like how the packet goes into the VM. So the first part, what happens is that we get the from our internet, then it goes to our Windows, which is our Windows 11 or 10 or Mac, and then it says where should I go? Should I go for should I move to another? Should I go through your Windows firewall? Is it related to your firewall? Like when we download some part, we get some malicious file, right? So where does it goes? Where does it uh, gets checked in the firewall? We have inbuilt firewall, the Windows Defender. So it checks that part. Now it goes to the open switch. So the open switch is this part, which is VMware. This now our VMware are mostly we connect our VM workstation with with the Ethernet. So which is our PCs, right? So from the VMware we get the NIC, and in there we choose the NIC part, which uh, what are we putting this VM? in which an IC into. So it's the network adapter part where we connect to the internet, where we connect the VMware to the internet. And this is how the application will start then. So this is the short one, your internet PIC, and this is how this diagram works. So the process we talked about earlier, it's talking about the diagram. So this is the more simpler version of this slide. PNIC receives the packet. That means our laptop receives from the Google, and then the Y, then those. Uh, See, now most of the request from the ChatGPT is going into the memory, and the CPU processed, and then the CPU processed that, which is our IRQ. IRQ is internet request, or I forgot. Yeah. Okay, then CPU hands the control finish the packet and OS and blah, and yeah, this is what then happen. OS passes the nerve to it. But if the ChatGPT was open in the VMware, this part, the memory part, it will switch to the Ethernet section. And yeah, this will how the process will work. And puts the RAM into that, it makes the parser. Now all the so this is the inside of us. Just this from the should get it. It fixes an IC made by the. So yeah, the same thing. So instead the chat GPT running in my PC right now, when it runs in the VMware, it will go through this one. IRQ inside the VM, the CPU inside the VM is a vCPU, VNSA, a packet place processor. This is a virtual interrupt, and okay, interrupt request. So IRQ is called interrupt request. So just like an interrupt for IC, the VM, and yeah, very good. This was a very good explanation. Obvious. Open vswitch. So this part, instead of going through all that process of first go through my windows, then find the firewall, what else, the what does this mean is that go directly to the VM. Any packets that come from the ChatGPT in the VM, it will act very fast. It won't check whether I'm using Windows, which kernel I am in. It will be a separate environment completely. So the process will be more smoother. So going through our firewall, it will be going through the VMware firewall. So this is the process. Staff only, YouTube, all of this run in the user read write scheduling. So what OVS, it's very simple. And yep, connect VNC, no hardware, just want to overcome the impact on the. And so we have this part where we each VM will have since each VM has its own Ethernet switch, right? So it wants to avoid having a multiple connection on the network adapter. So it will have a one more. Each of them will be directly, the VM will be connected directly with this VM, or there will be a Hyper-V. So this is what it means. And the set of faster that can bypass the thing of turbo boost. It runs it like a normal app. So we need to increase the performance of the VM. So it needs to avoid the Windows itself. Allow VN have two PCIs. PCI is the physical internet port, so it means this. So we will have the direct connection to the from the VMware to our from to the Ethernet port, to our laptop Ethernet port. So SRV, let's multi. So now we have now we have one few limited, right? So how can I let it share? When I create 5 VMs, it will use this concept, which is SRUIOV. SR single root input virtualization. Like within the VM net 1, it will pass to all the VM connected to it, a way to flex into many fast virtual NIC for VM. Let's multiple share one, but each VM gets its own directed to that NIC. Tonga, you have one internet cable. You SR with OVS. So now with the normal OVS, we have to in the VMware we will be using the switch method. It will connect to the network adapter and all. So instead of that, they use this part, which is the physical NIC of the VM, with the direct connection to our VM. So our VM is directly connected to our laptop connection. That's what it's saying, and there will be a main PF that will which will be connected with the VEB, virtual Ethernet bridge. So instead of our PC, our laptop deciding how much internet does it goes into the VM, within the VM they will decide how much internet should it be shared among each other. So this is that concept of SRIOV, and creating one core switch, which is like one core port, main port, and that port will let you distribute. Okay, so now Cisco created its own virtualization hardware where it contains all these appliances: virtual router, firewall, and LAN, and third party. So when now, as the same process, the it wants to trigger the monitoring uh, they want to monitor when the device is going up and down. So so they created this they created their own Cisco for this. Now NFV is based on Linux with now it's talking about extra stuff, and plug and play orchestration. ENCOR are supported for the orchestration role based. So, and this is where the Cisco SD-WAN, if you see it, it has the you can enter it through the dashboard. Once there's a connection from your remote uh, office, like you have another branch, and it connects to the and the service provider, you connect to the branch office ISP, and then that ISP will have a connection with your server, which is your main router. So you push that configuration to the branch, and that's what it means by plug and play. Within that, you will be able to see when it's going down, what are the switch ports, and you have the automation languages available, and then you have the role based who can access and what else, and that's where we end our virtualization concept. Thank you for watching me, and I hope you understood most of the concept. I wish you guys all the best for the virtualization concept. Thank you.